Hi and welcome. In this video tutorial, I am going to discuss about the interfacing of a mechanical push button with 8051 and how to write a program to check that our switch is pressed or not. Here in the Proteus ISIS, I have a switch connected to port 0 pin number 0, and this resistance network will act as a pull-up resistance network for my push button, and the other end of this push button is connected to the supply ground. In the Proteus ISIS, if you want to get a push button, then search for button and select this SPST push button. I will turn on this LED connected to port 2 pin number 0 when I will press this button, and when I will release this button, this LED will get turned off. I have created a new project in MikroC compiler for 8051. I have this switch 1 connected to port 0 pin number 0. LED is connected to port 2 pin number 0. I have defined two constants to turn on and off the LED. I have also defined two new constants, pressed and released, which means when our switch will be pressed and when it will be released, what will be the status on the pin. So when a switch will be pressed, it will provide 0, and when it is released, it will provide logic 1. First of all, we need to make the switch pin is equal to 1 so that it can accept digital inputs. Then I need to create an infinite loop with the help of while 1. If switch 1 is equal to pressed, now pressed is equal to 0. Here I have defined this pressed and released, so indirectly if our switch 1 is equal to 0, this double equal operator is for comparison, not for assignment. So if the left hand side variable is equal to the right hand side variable, then we have to execute the instruction inside the body of this if statement. So under this if statement, I will turn on the LED is equal to on and semicolon. Now I will copy it and paste it here. Now I will check the release of push button. Now if switch 1 is released, then I have to turn off the LED. Here I have two if statements. In first if statement, I am comparing the switch 1 status with pressed constant. If it is pressed, then turn on the LED. In the second if statement, I am comparing the switch 1 variable with the constant released, and if it is true, and then it will turn off the LED. So go to build and compile it. In the Proteus, assign the hex file and set the clock frequency and run the simulation. Now in the simulation, we can see the status of port 0 pin 0 is high and the status of port 2 pin 0 is also high. LED is off, switch is released. So if I press this switch, you can see this LED is turned on. The status on the port pin, the status on port 0 pin number 0 is 0 because of this blue color, and the status on this port 2 pin number 0 is also 0, which is turning on this LED. So if I release the button, the status on port 0 pin 0 is returned back to high, and it is also turning off the LED according to our program. Instead of using this second if statement, I can simply replace it with else statement, and there is no need to mention the second if statement when the switch is released. Remember that I am using this switch in pull-up configuration. We cannot use port 0 directly for digital inputs and outputs because we need to use the external pull-ups. So here these resistances are also required for the port 0. If you want to know about the interfacing of a push button with any logic circuit or a microcontroller, then refer to this video tutorial, and the link will be in the description. Thanks for watching the video and don't forget to subscribe the channel.